Hello, hello, hello. Hello, everyone. How's it going? Okay, this light is not helping. Uh, okay, let's try this angle. Maybe. Okay, I think it's fine. Hello, hello, hello. Anyways, I'll be off screen for most of the times. So it should be fine. Hold on. Now, this is annoying me. Okay, much, much, much better. Okay, hello, everyone. Once again, I've said hello so many times. But always glad to have you all here. How's everyone doing? Let me just remove this banner since we have started. And yeah, welcome to part 5 of Build an AI powered personal finance tracker. Okay. And over in the past, we have done like in the last 4 sessions, we have built quite a lot, I would say. And this is part 5 where we take everything that we have built and add the AI bits to it. Now, depending on like I have 2 sessions right now, so I have this part 5 session. I'll also have the next one, which is part 6 session, and in those 2 sessions, I want to cover as much AI bits as possible. So that is my goal. Now, folks who are joining for the very first time today, like directly on part 5, well, I would say courageous, and thank you so much for joining. Uh, okay, so what I'm going to do is I'm going to give you a quick overview of what we want to build, what we have been trying to build. I'll showcase what we have built. At the end of part 4, we did not have two things which I'm going to share, and then I'll show you the code of what changes I've made and how it works, and then we'll start building the AI. I'd say AI, but more like machine learning model, which would be very simple, very basic, and it will try to kind of understand from uh, our seed data. So we don't even have real data. We are using seed data or like fake data, kind of, which I've asked. Which I asked, I think Copilot or ChatGPT, one of them, to generate. So it is, yeah, going to be fake data, and we'll use that. But I think in the past, most of the questions were like, can we replace it with real data? And of course, you can. Okay, so before we go any further, let me give you the check-in link. And while you are completing the check-in form, let me quickly introduce myself. My name is UT. I mean, my name is Utkarsh, but I prefer to go by UT because that's how everyone in Major League Hacking knows me. And as I said, this is part 5 of Build an AI powered finance tracker. And this is a React project, completely front end. In the last 4 parts, we have built most of the UIs, like I would say complete UI. So this part would be focusing just tiny bit of UI and more on the ML side. All the parts are available on the YouTube channel of Major League Hacking, so please go and check it out. Uh, Other than that, you can find the code, everything that we have built, on my GitHub account. So let me give you a link to the GitHub account. Nice. Okay. So that is the link to the GitHub account. That's where you can find all the code that we have done in the past 4 sessions. So if you are interested in building your own, improvising it, improving it, or making something better out from what I have built, please feel free to do so. I have no issues whatsoever of whatever of what you want to do with the project or with the idea. So that is kind of what I want to say about the project. Now, let me quickly run the project. And local groups 5173. So this is what we had at the end of like 4 sessions. Okay, we did not have. Uh, okay, let's talk about what we have, slash what we had. Sorry, and then I'll talk about what we did not have now exists. So we had built a finance tracker dashboard where we could see all our like our total income per currency. So based in euro, based in pounds, based in INR, based in USD, uh, how much, like what is the income, what is the expense, how much balance, and total number of transactions. So in this case, there are 94 transactions. Okay, so this is built using. There's a question. What am I using? I am using React, and the charting is built using lightweight charts, which is from TradingView. If you don't know, so I can share that link. So TradingView is one of, like, this is not a sponsored post or anything. This is one of the charting libraries that I recently came across, and I found it pretty interesting. Uh, so yeah, here we are. And what else? Okay, I like this better rather than that. Okay. Oh, oh, sorry about that. Uh, yeah, I'm using Mac, and that is VS Code. Yes. Okay, so yeah, going back. So all this data that you see on this, like in these cards, they come from the data seed data, which has like all the fake data that we have created. So this is one thing, basically. And then we come down to the charting bits. So in the charting bits, the projected expense and projected income, these are again some like fake data which has been added here in the seed projected transactions. So it has a few projected data like one, two, three, four, five, six, like the six uh, objects, I would say. Six objects of some projected data, some fake data, and that is what is getting plotted on the chart. So that is a monthly trends chart. Then we have the expense category where we have expense breakdown by category. So these are different categories that we have in our data, and this is just showing those numbers. Then if you switch between one chart, like one currency to the other currency, the charts are updated. Like everything gets updated on the fly. We store our data in index DB. So if you are not aware of what is indexed DB, then like right click on any page, inspect, go to application, and there we have three kinds of storage. We have local storage, then we have session storage, and then we have these index DB. We have a few others, but this is where I stop basically. IndexedDB. So IndexedDB is persistent storage in the browser where you can store like anything. Technically, it works more like a SQL-like database, but more you can store data in a NoSQL format. So you can store like objects, which is key value pairs. I have named my key value as literally key and value, but you can have like a lot of keys, lot of values, like proper JSON can be stored here. And as I said, it works like a database because ideally what you could do is you do everything that uh, you do in a normal database. You will open a connection, you will start a transaction, you will save one thing and then get like, I don't know, success, failure. You can track all of that. So we use a library called XC.js. Okay, we use this library to kind of communicate with indexed DB, and think it works like pretty well. Like rather than using the raw APIs for IndexedDB, DexCJS provides like very what's the word? An easy to use option. So if you actually go through their documentation, you'll find that most of the words like just make sense. Uh, I think what I had was table.get. If I want to get all the data, I can give it a key and I can find a value for that. If I, what else do I have? There's a bulk get to get uh, values of all the keys together. Uh, you have, if you want to delete something from table or delete a table, I think, uh, delete an object from store. Yes, you can do table.delete. Uh, Collection is a collection of a lot of tables, I would say. So yeah, I think all of this, like these APIs, they make much more sense in terms of usage, in terms of wording, and also in terms of documentation. Okay, so that's about it. There is a question in the chat, which I think is a really good question. If we start using real data, would it make sense to use an actual database rather than local storage? So depends on what you want to do. Example, if let's say I host this project and I don't want to connect to a database because well, database costs money most of the times, but local storage is free. So I say local storage, but this data would be persisted. Like where did it go? Like this data is technically persisted unless you manually go and delete it. Okay, so this data would be persisted. So if you host this website and then if only you use it, then you'll always have the data. But if you think that there is going to be a chance of you sharing this with others and they have to also see it, then of course you'll need database. But then comes the question of, do you need database or do you need a place to store the data? Because what you could do eventually is have this UI, but connect it to Google Sheets. Okay. So from your UI, connect to Google Sheets. I'm pretty sure we have had a project. So if you watch, if you go to previous streams of Major League Hacking, I think there was at least one stream about connecting to Google Sheets. Yeah, there was a stream about connecting to Google Sheets from a UI. So you can use technically Google Sheets as your backend, and that's where you would store most of the data. So your data is safe; it would be visible to anyone you share the website with, but then it would be visible to everyone. So then you need to add uh, another layer where you would first authenticate a user, and then uh, show them, I don't know, your monthly income and expenses, right? So it makes sense, depends on what you want to do. Uh, Two options: if it's only being used by you, which like, in my case, I would only use it. So it doesn't make sense for me to kind of have a database. If you want to share it with people who can see your like all the details that you put in, then maybe share. You use a database. Okay, so okay, so this is what we had at the end of first four sessions. It was, as you can presume, slow session. Like all four sessions kind of went slowly, but I'm 100% sure people would say we learned a lot. We definitely learned a lot in those sessions. Okay, so now what I built after the session, which I had the code for. Okay, so it's not like I built it in like 10 minutes or something. I already have created the whole project. So what I did was copy paste the code, and what I copy pasted was a transactions table and a add transaction form. So these are two things that I copy pasted. Let's quickly go through it. Like this makes much very like this is very easy to understand what we are doing here. There's a transactions table. where all the transactions that are in the seed data and any new transactions that you add will show up here. Okay, and it has a very simple date filtering. So, like not filtering, sorry, sorting. So you can sort by date. The description category, like all these columns, are not sortable. I've not used any library for it. So you can actually find all of it in the transactions table right here. So this has everything. So I've literally just created a normal HTML table. Okay. Starts with a normal HTML table, create headers and the body. In the head part, you have all the column headers, column like basically column names, that is column headers, and then you have respectively we loop over the data. So there is a function which sorts all the transactions. Now these transactions are the projected transactions or the uh, actual transactions. We treat all transactions as actual transactions. Sorts over the data, puts it in the table, and yeah, that's it. So income and expense. Okay, you have two types of uh, data there. You have income, you have expense, you have your currency symbol, which tells you which currency it is, and if it is a projected transaction or if it is an actual transaction. Those are two things that we have. What else? You have a delete button, of course, and that's it. If I go over to the transactions tab, this is where you can enter your like expenses or income. You have to give it a description, amount. So there is very minimal validation. Yes, there's very minimal validation currently in this on this page. So example, if I give a description of grocery shopping and I create click on add transaction, it says please fill this field. This is very important. So I say that I spent like 12.45 pound, and this goes into none of these or none of these. Primary credit card. Interesting. Did I delete something? Ah, okay, that was a mistake. 12.45, primary credit card, pound, groceries, Tesco, and add transaction. Transaction added successfully. Now, if I go here, what is today's date? 17th. So it should have been added on 17th. Here we go. And 12.45 is an expense right here. Okay. If I go for a date in the future, like let's say for some reason I know that on 2nd of January I'm going to do grocery shopping of like 15 euros, and that is going to, or let's say it's not grocery shopping, it's dining out. Let's say buy office lunch, and it's dining out and it is lunch, and I add a transaction. There we go. That should be up top here. Oops. And it's right here. Since this is in euro, 15 euros, if I go into my this one, there should have been one more entry. Now I have three entries. Previously I only had two. Now we have three entries. So yep, that is everything that we built at the end of 4 sessions. Okay. These two buttons, they currently do not work. There's an illusion that it works, but they don't work. Okay, cool. So that is everything on the recap bit. Any questions, anyone, about it? Okay, cool. I would presume that there is no question and everyone's just happy about everything. So that is good. Let's see. Okay, so the next bits that I want to build is in this add transaction for this suggested AI. I'm curious. I'm pretty sure I have messed up on something. Hmm, okay, so I have a bug in the current code, which I just realized that for some reason this category is not getting counted. Okay, so that is something to look at. I can add a quick issue there for it. There's a bug when in add transaction tab under income section, user is unable to add income. It keeps showing an alert of add category. Was it? Please select a category. And this is a bug. It's a good first issue if anyone wants to take it. And there we go. Perfect. So there's also a bug if anyone wants to quickly fix it and what's the word? Contribute to open source. Okay, cool. So the next thing that I want to do is I want to generate and save a demo model. So we'll create a demo model using the seed data. Now the data that we have is not much. It's 96 transactions, for example. Okay. And locally even it's even less. It's like just 94 transactions, 94, 93 transactions in the seed data. So I'm not going to download the data from IndexDB, or actually I can. Okay, let's think about it. Hmm. Nah. I'll just generate it from the local data that we have for the time being, and then we can quickly add something to kind of read from IndexDB and yeah, create a model. The model's aim would be that when I click on add transaction and I, let's say, add some description, it should auto fill the form for me. So I'm going to step one, do that. That we are going to train a very simple, very inaccurate, I would say, model because the amount of data that we have is not much. I think that would take our first session. In the second session, my aim is to basically show you how to train a bigger model, like which would be better, kind of, in terms of uh, code, in terms of the predictions, in terms of I'd say comparatively better. Okay, let's not get our hopes up. I'll say it will be comparatively better. And in this case, the data would not be just these 94 transactions in C data. It would be 13,000 transactions in a CSV file. Okay. So we will read from a CSV file. I will provide you the CSV file, of course. We'll read from a CSV file. We will train, like create a TensorFlow JS model where we will train that and we'll train that model. We will, what's the word? and will use it to predict my next year's income and expense. Okay, so based on this year's income and expense, it will predict my next year's income and expense. And I think that would be the second session, which will be right after the first session. Like, sorry, that would be the sixth session, which would be right after this current fifth session. Okay, let's go. We have a lot of folders, so I'm going to create a new folder called as ML. ML is fine. Yes, ML. And this is where we will create our generate and save demo model to index.db.ts. That is a huge name. Okay, and also for you to see the screen clearly, we go. Okay, let's start with the import. Yeah, sure. We're going to import star, which means everything, as tf from @tensorflow slash tfjs. Okay. This is where all the libraries, all the APIs, sorry, all the APIs of TensorFlow.js would be available. This is one of this is not one of this is the way of importing it as far as I've seen in all the documentations. Next up, we are going to create a few things. I'm going to say demo labels. Okay. Our demo labels will be a string array, and this is where the magic will happen. Okay. So our labels, these are going to be the target categories that the model will try to predict. Sorry. And now, if this is your first time learning about ML, let's do some theory bits first, and then we will go into writing the code. It might be very simple for a lot of you. It might be repetitive. It might be very basic for a lot of you. So I would but I would suggest, or actually, I would request that please do stick around to help others who are very new to this. Okay. So yeah, that would be my one request for you all. Like, even if you know, please do stick around, help others, help the people in the community to learn. And if you don't know, then please stick around and learn right now and ask for help, ask questions. Uh, okay, so in our case, let's start from a few things that we are going to create. We are going to create demo labels, as I said. So this is like the names of possible output categories. Now, example, if we go to our seed data, we have possible output categories defined technically. We have these seed categories which have these ID. Like either it could be a grocery expense, it could be a Tesco grocery expense, it could be Sainsbury's grocery expense, it could be other groceries expense, it could be a dining, it could be a coffee expense, it could be lunch, it could be subscriptions, It could be utilities, it could be internet, it could be like gym, electricity, water. Like these IDs, they are that is technically what uh, our label would be. Okay, so when the model gives an output, it will say that based on what you have typed. So I will go into description and I will say grocery shopping. Then it should kind of understand like grocery shopping based on like these words that I've said. It must be a grocery category with a subcategory of Tesco. Okay, so that prediction is what we will have in the demo labels. So technically this is the possible output category. So from that one, it will then try and understand that, oh yeah, if the user has added like Tesco shopping or grocery shopping, and then the prediction is this EXP groceries Tesco, then it means it is a Tesco. Uh, like the subcategory would be Tesco, it would be type of expense, and it is for expensing groceries, for example. Okay, so that. Then we have demo vocab, another thing that we will create. Let me just create it very quickly. Okay, demo vocab. So this will basically have a small list of keywords. Okay, now we will convert this to a bag of words. Okay, now what is bag of words? So think of it as special keywords. Okay, so bag of words would be our special keywords, and these special keywords help us kind of understand or help the machine learning model understand where am I going towards. Example, I could just have the word grocery, or I could have the word grocery. Okay, both of them technically would denote some kind of shopping slash expense. Okay, now we would have like ideally we want to have this vocabulary of words as much as possible, as big as possible. But in our case, we will limit it to a very short vocabulary. I would say like 20 or 25, like that. That is what I've done when I was building it. So it would be very short vocabulary. But the idea is that typing groceries or grocery should trigger the same response. Okay, it should learn from those bag of words, like it should learn from those words that we are writing that, oh, yeah, I'm pretty sure that this is the keyword for an expense. Okay, Tesco is a keyword for an expense of like buying from Tesco, or Sainsbury's is a keyword for buying something from Sainsbury's. By the way, if you're not from the UK and you're kind of overwhelmed about what is Tesco, what is Sainsbury's, it is this. Okay, so yeah, this is Tesco and Sainsbury's. They're online supermarkets, but they also have a lot of other stuff. Again, this is not an advertisement to any of these. They have a bank, they have their own mobile. I think this also has a bank. It has uh, not just groceries, it has what uh, clothing, it has appliances, it has a lot of like in Sainsbury's has a lot of things. Okay, anyways. So these are my go-to shops for grocery shopping. That is why I'm focusing more on Tesco, Sainsbury's, and all those words. Okay, so yeah, so that would be our demo vocabulary. It would have this small fixed list of words or keywords, which would basically be telling our model that use these keywords, and if someone types these keywords, then you should kind of understand what they're hinting towards. Okay. Then we will have a function which would be pre-process data. Okay. So pre-processed data, what we are going to do is we are going to pass it the text that we will kind of have from the seed data, for example. So from seed data, we will pick up some text and we will pass it to this function. This function will ideally convert all of it to lowercase, remove all the punctuation marks. Uh, if there are spaces, then it would kind of remove the spaces, uh, or we'll try and split it on some spaces where uh, words are differentiated. So very simply, it's a function which will clean our data. So that is the next thing. And the next one that we are going to do is we'll have a function to convert to bag of words. Yes. Okay. So this function, this is going to create uh, one a vocabulary of words, and we will increment when the word appears in our data. So example, if here we have the word grocery and we pass it the data of, where did it go, transaction. Okay. Now every time there is a word in from like word in the data which matches the demo vocab, it will add it to its it will increment its counter. So that ways it will know that, hey, I know that this user spends a lot of money shopping for groceries, so that must be very important. Okay, so this is our way of kind of creating this. Uh, how can I explain it easily? Let me think. So we're counting the number of occurrences because then when we do a prediction on what the user has typed, we'll have a very solid foundation on what I'm hinting towards. So if I have a lot of transactions which have the word Netflix in it, then it knows that next time I would type the word Netflix, even if I have space in between, or if I don't have space in between, or whatever is the case, it would understand that I'm paying for that. This should go into an entertainment category. It should be an expense. I normally pay it from my, I don't know, one of these accounts. I normally pay it using, like, let's say, my primary credit card. So it should understand, uh, it's not, it should, it would understand all of this based on how many time, like how much data I have, how much enriched that data is, and when it was building the model, how many times it found that word and then kind of kept it in its memory. Okay. So that's one way of understanding it. Then we will have another function which would be label index. Okay. So label index. So this will map a category string. I would give it. Okay. So we'll give it some category ID and it will map it to the index in the demo labels. Okay. So in the demo labels, if you, as I said, like, it will have exp dash groceries dash testo, exp dash groceries dash Sainsbury's, and now my label index, it will map a category that it has received to one of these demo labels. Okay, that's it. Very simple. Then we'll have, of course, the function to, yep, this sounds great. This is our main function. We'll generate and save a demo model to index DB. That is eventually what we are aiming for in this project, right? Sorry, in this file. This is eventually what we are aiming for. Okay, so the way this is going to work, number one, we will first load some seed, not some, we'll load all of the seed transactions. Whenever I say the word seed transactions, it means everything from the seed data file under this seed transaction, like from the seed transactions array of data. Okay, so yeah, we'll load all the seed transactions. We'll try and filter out or all the transactions which have a known category. Then we'll convert the description, okay, to the book of vectors, like the BOW to BOW. Okay, so we'll the description of every data right here. We will try and pass it to the bag of words, not book of words, sorry, bag of words, to bag of word function right here, so that it can build its index of most repetitive words. And then we will split our data. The splitting of data would be necessary slash helpful to check how accurate our model is. So normally you split your data into 80% and 20%, 80% for training, 20% for testing. This 20% of data is something that the model would have never seen. Why do we do that? So think of it as studying for an exam and giving the test. Now, it is quite possible that whatever you studied in your textbook is actually exactly what you get in your exam, and that is fine. So you would have something which you already know versus something that you have never seen, and that kind of tells you, like during your exam, your test, that how much have you actually learned versus if you have actually mugged it up and just you never actually understood anything. Okay, so that is what we do with these functions as well. Like sorry, these ML models as well. So if we have our data, we have like 94 transactions, or let's say we have 100 transactions, for example, for easy math. So if we have 100 transactions, then we'll split it into 80 transactions go to train the model, so that it can understand the transactions. It can use some algorithms to find patterns and build its model. Okay, or build a let's define it in a very simple way. It builds its intelligence. Okay, let's say that. So we are going to give it some data, and we'll tell it like this is what the data means. And how would we tell it? Using these functions. So these functions would have helped us kind of clean the data, so that when we give it to some algorithm, the algorithm has an easy way of understanding what the data is. Once it understands the data, it will try and build its intelligence based on how it understood the data itself. Once it has built its intelligence, we will give it a test. Okay. And we will see how many of those answers it got right. Okay. That tells us the accuracy of the model very simply. So we'll give it some of these, like we'll give it some, the remaining 20. So we gave it 80 uh, 80 of the data, 80 of the objects in from the array as a training data. The remaining 20 will be used for testing it, and then based on how it performs on those 20 uh, transaction details, or the 20 data set, will create something called as the accuracy of the model. And higher the accuracy, better is the model. It means it has understood much better, and it has understood everything. The problem is, if you go too high, example, if you score 100% in the exam, people are suspicious, right? Everyone is suspicious that there must be something that's gone wrong. And you cannot be like this smart. You have cheated. And that's what even happens with these ML models. So if you have a very high accuracy, example, if you have 99.9% accuracy or 100% accuracy, that means the model is, there's a word called overfitted. And what that means is that your model has kind of learned everything which is not technically possible. It's not humanly possible, but it's also not technically possible. And it's kind of going to fail in a real world scenario. And that has always been an observation. So we will use some things called as parameters. We will change some parameters here and there to kind of create a model with high intelligence, but at the same time, not with 100% intelligence. Okay. And that is because we don't want to overfit our model. So that is one thing. And what else? Mhm. I think that should be it. We'll also, of course, save it to IndexedDB at the end of it so that we don't have to keep training a model again and again. It's going to say, why do I have test scope? And I realized, okay, so we'll not try and create our AI model again and again. We won't train it again and again. We will keep it kind of simple. It won't be a very nice, very understanding model, and it won't be able to kind of handle a lot of words thrown at it. But I think this would be a very nice option to a very nice opportunity, kind of create something and see how it works. Okay. And if there's any questions or anything, feel free to ask in the chat. I'd be happy to answer if I know it. If I don't, we can always Google together, right? Okay. Let's. Oh, good morning. That is a very early morning, which is nice, or a very late night. It is 7:50, so 8 p.m. for me, basically. It's going to be a late night for me. We'll have this session, which will go up like for another hour. Then we'll have 15 minutes break. I'll have this session up for like one more hour, and then we'll have 15 minutes break, and then we'll have the next session. But I'm aiming that hopefully our next session would be way, way. We may finish quicker. Excuse me. Okay. So demo labels. Let's start with this. Now, since I have already created it, I am just going to copy paste it, and these labels, as I said, they so these labels are some things that are available in our seed data. So basically picked it up from there. We can have a few more like uh, and other labels, but I don't think that is good for this idea. We want named labels so that it's easily understandable. Then for the vocabulary of words, sorry, was answering a question. Okay, cool. So demo vocabulary. So this is basically the keywords that we talked about. Uh, for this session, I think this is like the simplest. vocabulary and the minimal vocabulary that we could have. Uh, okay, so that's why I'm kind of again going with some basic ones. Example, I can have salary, bonus, rent. These are some keywords. For grocery and groceries, I have some companies like Tesco, Asta, Sainsbury's. Uh, let's say I'm paying subscriptions, so Netflix, Spotify, ChatGPT, Claude. I should add Perplexity or something like that, like some keywords. So these are basically the keywords that are going to be used in this, uh, that are going to be used by the model, so that when we type it in the form, it can under see what it closely matches to, and yeah, assign the category and subcategory and stuff like that. So coffee, cafe, Cafe Nero is one of the companies. Starbucks, uh, gym, Wi-Fi, internet, use some utilities, dining, restaurant, lunch. Could have like technically dinner as well. What other? Okay, exercise. I need some coffee companies. Costa Coffee. Okay, yeah. Paul's. I think these are a few more coffee companies that I know of. So now these will help create a vocabulary which is much more understandable. Okay, cool. Then I'm going to create a new variable called as vocab underscore length, which is nothing but the length of the demo vocabulary. So how many ever we have here? Okay, that goes to the vocab length. We'll use it in the bag of words, or the bag of words. Okay, vectorization of bag of words. Oh, there is a question. Which model are you using? And does Does bag of words work as semantic search? Okay, so the model that I'm going to use is going to be a very simple feed forward neural network. It's, I think, also called as multi-layer perceptron. I'm not wrong. And what it is going to do is that it is going to read from one layer and pass it to the next layer, then pass it to the next layer. So we'll have like 32 neurons. So the simplest of model that we can have. Uh, if you want, I can try and explain. Mhm. Okay, I can try and explain what is like feed forward neural network if needed. And for the question of does demo vocab work as semantic search? Uh, or- I mean, bag of words more like. Yeah, that's the bag of words, which is technically my demo vocab. Is does it work as semantic search? No. So all we are going to do is uh, count the number of occurrences. Okay, a semantic search would be like if it understands some synonyms. Example. Okay, so at least that's what I think you're asking. So if I have the word as, I don't know, if I have the word as utility. Okay, so if I have the word as utility, I don't know what are the other synonyms of this utility. Synonyms. So at some point, for whatever reason, if I have if I write the word as viability or practicality in my message, in my description, can it understand that I mean it is going to be a utility? Uh, or uh, the other option, oh, let's go for an easy one. Yeah, if I say that matcha, okay, I guess, or latte, or cappuccino. Okay, cappuccino. So if I add the word cappuccino in my description, will it understand that I mean coffee? No, not really. All it like it doesn't really understand any synonym or meaning or context. It is literally going to be a string search. Okay, so not a semantic search. It would be more of a string search. And yes, we could do a, I don't know if there is a library for it. I think TensorFlow JS does allow word to vector. Yep, there we go. Hmm. So TensorFlow JS does have something that would allow us to do exactly what I said. Example, there we go. So if I say that expense cappuccino, then based on some of the synonyms, like for whatever reason cappuccino has a synonym of coffee, it would understand that I am trying to basically expense a coffee. Okay, so yeah, that would be ideal. In this case, it's not. This is very simply, literally a string search algorithm right now. But we can build what you have asked, and I'll try to build that. I will try to build that as part of the next session, or when I push the final code, maybe I'll try and improve the model so that it uses this word to vector and like from TensorFlow JS, if they have it available as I don't know, some API or something, that would be nice. I'll have to look into it. I'm not 100% sure if TensorFlow JS allows that. I think it should. It it does have some details slash some data like Shakespeare text. Mhm. Okay. So this is one helpful link for details on word to vector, which would have description of semantic searching. So definitely have a look at it. Oh, don't worry about it. I mean, like the whole idea is that I stop and explain things, so it's okay to ask questions. I was just like thinking, like, do you want to understand that or not, kind of. But actually, let me just explain it for everyone else. Maybe someone would find it interesting. So, as I said, like we're going to use a very simple feed-forward neural network, and what that means is that it is information going from one layer to other layer. Think of layers as houses, or okay, not houses, rooms. Okay, so I don't know what kind of hotel rooms I'm thinking of or imagining, but imagine that you are on a floor and you start with the first room, and for some reason you enter in the room like this way and you exit that way. You don't like, okay, you have some weird layout of the rooms. Okay, so a simple feed forward neural network is like entering into the rooms like from one way and what you're feeding to the next one. So let's say you enter the room and you tell it that okay, I have learned like around 50 words. Okay. So I've learned 50 words, 50 new words, uh, but I see that there are these 40 words that are more important, like because they have been uh, used more often. So then you pass that uh, 40 words to the next room. So as an input to it. Then that next room is like, okay, let me learn that. Now it passes some more to the next room. So it tries to like think of it as it's trying to learn from the set of words, and it can do multiple things. It doesn't have to reduce it it's not necessarily going to reduce the number of words from like 50 to 40 to 30 to 20 to whatever. What it is going to do is it's going to do some mathematical operations, where it will try and just jumble, okay, mix that bag of words and then pick up like it's 50 words or like it's 40 words, 40 important words. Then it passes it to the next room, and then it that does some math, mixes the uh, bag of words, and then it picks out its best words, kind of its most important 40 words or something. So that goes on and on and on up until it reaches the last room, where it gives you kind of uh, a number saying that, okay, in my opinion, after going through like these 32 rooms, in my opinion, uh, I have like the last room, it will say that, or in the last room, the person will say that I've learned that after these 32 rooms, that the most important set of words are going to be coffee, Tesco, Sainsbury's, and like in decreasing order. Okay. And this is a feed forward neural network. It literally goes from one to other to other to other to other. There is no kind of going back to say that, oh no, you were wrong. Actually, this is more important than what you have suggested or what you think is more important. So when you loop back, that's when you go into some complex neural networks where the previous layer gets a feedback from the next layer in a way. So this is like I go inside a room and I say like these are my top 50 words or most important words. I send it to the next room. The person in the next room reads, and then it comes back and tells me that, hey, I think these are the most 50 most important words. And I then process it again and go like, okay, yep, I think you are nearly right. I will take some of your suggestions and put some of my suggestions and give it to you. That these are the next, like these are the words that I think are most important, and that goes on and on per layer kind of. Think of it as that. Okay, so layers are like your rooms, and you pass the data through all the layers, and finally you get an answer which has for every word there is a ranking to it, okay, and how important it is or not important it is. Okay, so that was my simple way, or that was a way that I could explain neural networks slash I understood neural networks. Then we have different other types of neural networks, like very simply like convolutional neural networks, where it is normally used for images. So it looks for patterns around like edges, shapes, small parts of the images. Like it will take an image and it would kind of cut it into, let's say, 9 parts. Okay. And it will understand the colors and the edges. So let's take a, like imagine like there's my photo and it has to understand my photo. Like I give it my photo. The first layer in the first room, there is a person who cuts it into a Sudoku. So 9 boxes. Okay, it makes like one horizontal cut, two horizontal cut, three horizontal cut, four horizontal, vertical, vertical, horizontal, horizontal. So 4 cuts, and it ends up with like 9 pieces of my photograph. It understands like in per piece, like what it has captured and what that means. Then it passes that to the next room, and in the next room, the person cuts each of the chunks, like each box that it has received, into nine other boxes. Okay, or like yeah, and then it has a better idea, because then now it has kind of captured some nuanced features which the previous one did not, and then pass it to the next one, and the next one again. It takes each of them and individually cuts them into nine pieces. Okay, so as it goes on and on and on, at every layer, they actually reach to a point where they understand the color, the shape on every pixel of my photograph. So next time when I send my photo to them, they can take a look at some of the features, not the face as whole, but some of my distinctive features, and recognize that it's me. Okay. So that is one way to explain convolutional neural network. So you break it down in smaller and smaller and smaller chunks over different rooms. Like in every room, there's a person who's like who's an expert in chopping up photographs, basically. Yeah, that's how you would do convolutional neural network. Then what else do we have? I think there's like RNN, recurrent neural networks. Recurrent neural networks, yes, yes, recurrent neural networks. So what it does is, um, let me think of an example. Okay, so think of it this way. So imagine that uh, you have to, yeah, you have some data, you have some finance data, example. Okay, you have some finance data, some stock trading data or something. I'm not 100% sure if RNN is good for stock trading, so please don't take my word for it. Uh, uh, okay, so think of stock data. Let me see if I am right with this or not. Time series prediction, RNN. Yeah, okay, cool. So recurrent neural networks, or RNN, think of it as I said, like think that you have some stock data. Okay, so stocks data you have, like, I don't know, Google's stock data. Yeah, okay. You have stock data of Google, you have stock data of Apple, and you have been following it for, like, I don't know, last 20 years, and you have all the data of last 20 years. And now you want to predict that tomorrow, will the stock go up or down? Now imagine, like, in a world where a news, like tomorrow, like let's not assume that tomorrow there's going to be a news or something, or let's say actually there is news. Let's assume that tomorrow they are going to announce their quarterly result. Okay, so now you want to predict that whether it will go up or down, and you have fed it all the data that you could find with respect to those stocks. If assuming that they always announce on the same day and every condition is similar, would it go up or down is what you want to uh, kind of predict. Yeah. So in this case, a recurrent neural network, it will allow you to, the way it would work is that you give it that data, it is going to try uh, finding some patterns, it will try and find some sequences, and it's better for things like these time series data, like over the time of how things have happened, let's say, uh, because it can remember what happened before. So it remembers what happened in the previous room, and based on that, it can improve itself to do something clever. Okay, so let's take off the stock data. Let's think of that photograph example. Okay, so assume that in the previous room, I like in the first room, I cut the photograph into 9 pieces, and for whatever reason, like my face is only in the middle of the photograph, everything else is empty. And now I pass it to the next one, like in the next room. If this is a recurrent neural network, what it will do is it will remember that in the previous room, I have noted that, hey, the face is only in the central one and everything else is just empty. There's nothing, no data there. Then recurrent neural network will make a decision, like the person there in that room is going to make a decision of only going to cut the middle box, okay, into 9 pieces rather than cutting everything else into 9 pieces. Because even if you cut a white box into 9 pieces, you end up with a white box. So it doesn't make sense. So now it has kind of not simplified, it has now focused its energies on the important data and ignored the noise. And now it passes to the next one. And that one also knows what happened in the previous one. So it doesn't cut those empty boxes. It only cuts where there was data, where I had my face for whatever reason. It's so weird if my face is only in the center of a very big frame. Okay. Right. But do I not have a neck or something? Okay. And then it cuts that one into like small pieces. So recurrent neural network, it knows what happened previously. Photo is not a very good practical use case for recurrent neural network. It is better for time series data. Like, what is time series data? Stocks data is time series data because over a time, you have certain patterns. Okay, so that's my pep talk. Thank you for coming to my pep talk. And now let's go back to what we want to build. Okay, pre-processing, very simple pre-processing. Okay, what we want to do is return. Okay, it needs to take some input. Well, yep, yep, this sounds right. So it should take some input, ideally text, and it should return string array. It cannot return a string. Just a string would not be possible. So text dot to lowercase number one. That is what we want to do. Convert everything to lowercase. All the uppercase words become lowercase because then it makes it easier to search and compare. Okay. Then we are going to replace all the punctuation marks. We are only going to keep the words and letters and numbers. So letters, numbers, and spaces. Yeah, let's keep spaces. Okay, cool. So what we want to do is we want to write a very quick regex. How do you all pronounce it? Regex or regex? Well, you can't say it out loud. Uh, so I'm going to say small a to z, 0 to 9, okay, and spaces. And this is global matching, which means replaces all occurrences and removes it. Like it finds if it finds anything else, if it finds any punctuation marks, it adds a space there. Next is replace. And I'm going to say that replace all like multiple spaces. So if in a word there are multiple spaces, uh, this looks right. Okay. So in the word, so since we have replaced everything with a space, now we can have words which will have like pre-space process. We're going to collapse those multiple spaces, then trim them to remove extra spaces, split them, and now I'll add one more thing, and I will filter out boolean. It's basically my way of saying that there must be a word here. It cannot be empty spaces. Empty spaces cannot be tokens. So we are going to get words which have some meaning. Not some meaning. We'll have words. We'll not have empty spaces. Now for to bag of words, we're going to give it tokens, which is nothing but going to be a string array. And now this is going to return a float 32 array. Okay. So if this is, oops, what did I do? Yeah. This is your first time looking at it. Uh, quick recap. Yes, a quick recap. So what we are going to do is we are going to create bag of words. This is going to create a vocabulary where we are literally just counting how many times a certain word appears. Now, this is going to be very simple. So, example, if I get the word internet, then the word internet has the word net in it. Okay. And we are going to use substring matching, like literally substring matching for it. But it will also cause problems because if I get the word rent, it may think that, oh, I think the word rent is part of the word internet. Well, actually, no. If it gets the word inter or a font, okay, there's a font called inter, or let's say if it gets the word int, which is integer, then it would think that, oh, it's part of the word internet. Okay. So this will cause a lot of false positives. It will cause a lot of problems, but that's fine. We are, again, as I said, we are building a very simple network. Okay, cool. What's next now? Let's going to create const equals new float 32 array of this uh, for let's do tokens dot map token and perfect. Okay, this is what we eventually want to do. Okay, so what we are doing is we are looping over a string array. Actually, let's simplify this. Let's use a normal for loop. Okay. Mm, let's see. Is this correct? It doesn't need to be equals to. Yeah, you can just do a token dot includes. Hmm, okay, and we can return. Okay, this sounds good. Cool. So what are we doing here? So as I said, we are going to let's think of an example here. So this one, if given a string, so this takes an input as a string and returns a string array. So if I write like groceries at Tesco, comma pound 45.50, then it will return me groceries. To return me groceries as one word. Uh, yes, at, then it will return me Tesco. It will not return me the comma. It will return me 45 and 50. Okay. So this is what is going to, like, this function is going to return me this. Like, given this input, if this is the input, then the output would be something like this. Output would be something like this. Perfect. So that goes to the bag of words. Now, in bag of words example, what would happen is we are giving it an array of words. So, example, if this is the input, then in that case, the output would be, assuming it saw the word groceries one time. Okay, it saw the word at, like, I don't know, uh, 20 times. Saw the word Tesco like 3 times. Uh, it saw the word 45. Oh, if this is capital G, let's say, it will still become small. Okay. It saw the word 45 like 0 times. It saw the word 50 like 1 time. Now, this is not the real representation, uh, but the idea is something like this. Okay. The idea is something like this, that given these things, if the word that you see, it includes something from the demo vocabulary. So if I have the word, do I have the word in or gym or Pulse or Costa or Nero or cafe or coffee subscription. If I, for whatever reason, I have the word script, okay, if I work in movie industry and I have the word script, that will be a false positive because subscription also has the word script. Okay, so this includes is not a very good idea, but in our case, I will take that leap. It's fine to do that. Okay, so yeah, in our list of demo words, it saw groceries example, then it will increment it. Okay, so yeah, that is the idea, but it will not be exactly like this. It mostly be all zeros and stuff. Yes. Mm, because how many do we have? We have one, two, like, from 18 up until 44. So this array will be like initially 0, 0, 0 up until like whatever numbers, and then every time it we give it an input, it will increment the word at that particular position. For example, okay, something like this. Yeah, that makes much more sense, right? Next is label index. Okay, let's go there. Label index. This will have a category ID. Yep, and that would be a string, and this will return me either a number or it may return me null. Okay, so what is this going to do? So in label index, it will convert the category name into a numeric class index. Okay, example, in like very simply, what we will do is, yep, this looks good, and this looks This is wrong way around, right? Actually, it's the correct way around. Okay. So, label index. So if we give it the word, or like if we give it the category name as what category names do we have? We have in INC bonus. Okay. So assume that the input is INC bonus, then it will try and find it where that exists in the demo labels. It exists as 0, 1, 2, 3, 4, 5, 6, 7. Yep. It exists at position 7. Yes, perfect. Yes. But if not found, it will return null. Okay. How do we check the not found? It's because of this minus one. This minus one, JavaScript, thankfully, tells us that, hey, I did not find the word that you were searching for. So sorry about that. And I could only return minus one. If it returns minus one, then label index will return null, else it will return the index of the variable. Why do we need this? Because then we are talking about numbers. Numbers are easy for any algorithm. Okay, like math is actually no, that's not true. Math is not easy when you only have numbers. You need some letters to represent some details. But in terms of for machines, uh, math is easy if it only has numbers. So we are technically using that to convert, like, get a numeric index for training purposes. Okay, this is for training purposes. And now comes the ultimate one, our very main function. Okay, I'm going to say that this is going to return a promise of void here. So what does that mean? That when this function is called, it will start building the model. Now it can take some time. It can take 1 minute. It can take 10 minutes. It can take 1 day, like all possibilities. So this is something that our function needs to know and understand and say like, yeah, once you have fired the promise, then you have to wait for it to be fulfilled. It is possible that it won't be fulfilled immediately. Okay, it won't be like you do something and you get a response. No, it's not synchronous. This is a asynchronous call. That's all we are doing. Now let's, okay, examples. Okay, that is nice, but we have this data in our seed transactions, comma, dot, seed projected transactions. Uh, didn't we? There we go. Seed all transactions. Is this a function? No, right? Hmm. Okay. So you could do that, or oops, my bad. You could do this, or you could do like seed transactions, comma seed projected transactions. Like to each their own. Uh, seed transactions all thankfully has everything that we need, so we could just do that. Okay. I'm going to do exactly that for the time being. Make our lives easier. Uh, this is not needed. That goes away. And this is unhappy because it has no await inside it yet. Okay, that's fine. Good. The next one is we are going to do a const filtered equals to examples dot filter. and we'll call label index of t dot category not equal to null. Okay, so what are we doing here? So from our example data has transactions. So each transaction has ID, date, this, and a category. Okay, now this is what we want to use. So category, so t dot category is passed to label index, and we are telling it that in the demo labels, find its position and return it to me. As supposing that it is not able to find a position, it's going to return the word null. Okay, like not the word, the data type null. So we are filtering out for any null values, and we are saying that don't give me nulls. Now, if like, some defensive programming, yes, if this is the problem, okay. If supposing it can't find anything, it can't find any details in the demo labels, then in that case, it will throw a error. It will give an error and it won't be able to train anything. Okay. Good. Okay. The next bit is going to be about what should we do? We'll have to create our XS and YS. And these are some like common names that people use. So I'm going to use that. And you will see, yep, as you can see, that even this one starts suggesting that, oh, maybe you want to create this thing. I'm going to say yes. Filter dot map t array dot from to bag of words. Now, bag of words needs string tokens. We'll say process. Is that what I called it? No, pre-process. T dot description. Okay. So what are we doing? So we are uh, basically creating an array of bag of words. So these are the input data, okay, that we are creating. And now let's create YS. So this would be filtered dot map, and I'm going to say that this would be label index of t dot category. Okay, I think that is good. Okay, so let's talk about what would be the input. So the description is majorly what's important to us. Okay, so if I go into a transaction and I go into description. Okay, so coffee dash bread. Okay, this will be passed as an input to preprocess, which will convert it to coffee, comma bread. Okay, these are the two things that would be returned as part of preprocess, and we convert it to bag of words. So we tell it that search for these two words, coffee and bread, all lowercase, in this demo vocabulary. If you find it, so if you find the word example coffee, increment that word, like the position at, like in the array, increment its position by 1. Okay, that is what is going to be detected. What that is what is XS is going to do, and YS. So this will ideally now return a numbered array. Okay, it will return an array of numbers. Uh, Now, what is YS going to do? So YS, we are saying that take the category and return the labeled index, which if I think, is it needed? Hmm, a filtered already has filtered out a lot of things. Let's leave it be. Hmm. So in this case, I'm not checking the null. I'm not doing the null check because I know for a fact that my filtered already has filtered out everything. Uh, Everything with respect to what's the word? Null values that will come. So I'm basically just taking the label index of that particular category and just mapping it to this ys. So ys is going to return me a number array. Hmm. This will always be there is something that I'm adding as a check. By adding an exclamation, I'm ensuring or telling it that yes, it will always be there. It will never be a null array. It will always have numbers in it because the nullish check has already been done. Perfect. So next bits, remember our training and testing sets. We divide our data set into two pieces. We have our training set, which would be 80% of the total data, and we have our testing set or testing size, which will be the remaining, like 20%, or basically take the total minus the training, and you're left with testing, right? So, so I will create const total equals to how much data do we have? The data that we'll have is equal to xs dot length. mm, Const train size. No, what if it only has one? So math dot max. I'm going to do it the hard way. Well, actually, not that hard. And const text size equals to math dot max. Yep, perfect. Okay, so what am I doing here? I'm trying to split the model, split the data into 80%. So I have total of, let's say, 100 data points. I am creating a training data set of 80% of that data. So math.floor will ensure that if I have an odd number here and its multiplication is being like a weird number, we convert it to something which is much more readable. And then what is the maximum between 1 and if this is 35? 35. So training size would be like 35 data points. And the testing size, again, between 1 and if let's say I have total of 70 data, or not 70, 50, 35 is in training. How much am I left with testing? So that would be 50 minus 35, right? Simple. Some simple math right there. Very difficult to understand. That's a joke. That is a joke. Okay, so that's my training and testing data split. This will ensure that our model, okay, our algorithm that we write does not overfit, or it does not like become the class topper by cheating. It needs to be humble. Uh, some lame jokes coming out, some weird reason. Okay. Next is we are going to create TensorFlow tensors. Okay. What is a TensorFlow tensor? It is basically uh, an array. Actually, before we do that, let me log a few things. data set sizes is going to be the total, the train size, and the test size. Okay, so this console.info, no, not happy, console.debug, perfect. Mm, yeah, I think this should be good. Perfect. I'm going to create a few access train. That is going to be access dot slice. Yep, perfect. Okay, so this is just us splitting the data for no purpose whatsoever, technically, but still with some purpose whatsoever. Uh, don't worry too much about it. Yeah, just basically slicing is allows us to slice the data. Okay, so we are saying that from 0 up until whatever this number has returned, that is my x slice. From 0 to whatever this has returned is my y slice, like ys slice. For testing, again, whatever is like the train size. Hmm, and ys test will also do that. Now let's do uh, extensor, and that is nothing but this one access train, comma this bit. Okay, okay, cool. What do we want to do? We want to create access tensor. Then we want to do a y tensor. Give me a moment. I'll explain this. We are going to do tf dot one hot tensor. Yep, and this will be tf dot tensor one d ys train. Uh, okay, cool. Okay, let's explain this. Let's get an explanation of what we are talking about here. So, uh, as I said, at this point, we are saying like the first 80% of the data is used for training and the remaining is used for testing. Okay. So, we are not creating data or we are not pulling like some random data, like, okay, not random data. But if we have like 100 data points, then we are doing like 1 to 80 goes into the training and 81 to 100 goes into testing. We could technically have data from like 21 to I don't know 90 goes into training and 1 to 21 goes into testing. So we could do all of those. So in this case, we are trying to kind of simplify, like keep it simple in terms of understanding how much data was used for training and what like which data is used for testing. That is why we are doing this whole split. So this is for like the first 80%, and this is for the last 20%. Next is the TensorFlow thing. Okay, like this whole tensor and one hot and all of that. So what is tensor? So TensorFlow JS is built normally to work with, not normally, this is how it's built. It is built to work with tensors. Okay. Now, what are tensors? Uh, Tensors are nothing but think of it as an array inside. an array. Okay, and yep, you could have that. You could also have like more nesting if you need for whatever reason. So tensors uh, are multi-dimensional arrays. They are not normal JavaScript arrays. They are multi-dimensional. Why do we need this? Because this way it will do the computation faster, and it will like optimize the memory, and it will ensure that it learns uh, quicker. So think of the in our case, what is the example? So what will it look like? So example in this X train, sorry, extensor. Why did I say train? Okay. What will this return? So this is going to return me like an array of 0, 1, 0, 1, let's say 0, whatever. Then I'll have like a similar array and so on and so forth. So this is what XS train would look like. Now when it comes to extensor, okay, the input to this extensor, oh, you already know the input, but what that would do, what would the conversion look like? That is going to XS train dot len would be, let's see, XS train is this. So to tensor 2D, our inputs are this thing. Then we give it an array, and in the array, we are giving XS train dot len, which is how many arrays are here. It has like two. Okay, so array inside an array. So it has like two of these arrays. And what is our vocabulary length, which would be, I don't know, 20 or something. So let's say 20. So that is what we passed to the tensor 2D. And now it is going to kind of understand slash split it out in a way that it is easier to understand for our TensorFlow.js. And it will say, okay, let me try and convert it in a format where it means like it has two examples of data. It has 20 vocabulary words, and it is looking at all these data points and seeing what is the highest occurrence of each word, kind of. Now let's talk about the Y tensor. Okay. So YS train, what is that going to return us? So YS train is going to return me like, uh, well, actually, this has a comment inside a comment. So this will return me ideally. So if I have like INC bonus and this, then it is going to return me the index of those, right? So it is going to return me the index of INC bonus, which was, I think, 7, and groceries Tesco was 0, right? So it is going to return me these two things. Now we pass it to the tensor 1D function, one dimensional tensor function. So that is going to convert it to integers, for example. Okay. So let's say this converts it to some number like, I don't know, 12 or something. And then it is going to be given over to one hot. Okay. So now this is interesting, man. So one hot, it basically creates a tensor, or it creates a ranking around it. So it's, let me think of an example. Mhm. Okay, let's think. So one hot would allow you to convert it to one number, okay? Or let's say, okay, not one number. Uh, mm, let me think. Let me think. Give me 1 second to think of an example. Like, what would be the ideal one hot tensor output? Let's see. Okay, let's talk about this one. Okay, so we have given it as an input to tensor 1D, and we have said like these are your category IDs 7 and 0. Now, when it's converted to one hot tensor, we are trying to encode it to something like some numbers or whatever, where only one of the output array will have some value. Well, so I think this is correct. Yep. Okay. So 7 means that if I have like how many things will I have in my array? That is determined by demo labels dot length. How many arrays will I have will be determined by demo dot length. Assuming like this comes out as 2, so that is why I have array inside array where I have two arrays inside it. Now, if like this 7 represents like INC bonus, so at the position 7, I will have a 1 and everything else will be 0. If EXP groceries represents like 0th position in my all my demo labels, then in the second array, I have that as 1 and everything else will remain 0. So this ensures that for every array inside, there is uniquely only one and everything else is 0. This makes it easier for the model to kind of work with uh, to work with text data by converting it to a ideal numerical format. Okay, an ideal numerical format where there is no clash. So now every word, like every category in this case, is uniquely identified by one array. By like you can say it's by position, you can say it's by where it is visible or like where it is truly. Like there's so many ways to explain that, like not explain, to think about it. But at the end of the day, instead of having an array of like 7 and 0, we have converted it into a very big array of ones and zeros where there will be only one and everything else will be 0. Cool. And that is my y tensor. And now let's create our model. Okay. Now this is where things are going to get interesting. So, okay. The model that we are going to create is going to be a sequential model, as even this one is suggesting, like the AI chat is suggesting. What's the time? Okay, we are nearly at the end. Okay, no worries. I mean, the next session is also mine. I think I can just kind of take go over, and that's fine. Okay, tf dot sequential. Okay, this is the model that we are going to use slash create. So sequential model, blah blah blah. Again, let's think of an example. So sequential is again, remember feed forward neural network that we talked about. Actually, we talked about this already. We don't need to talk about it again. But very simply, it's a type of neural network where one layer is going to give data to the second layer, then it's going to give to the third layer, then to fourth layer, to fifth layer, blah blah blah, up until it reaches the last layer. So in our case, we will have what's the word? A sequence of it. It's like a connected linear chain of layers, okay, where each layer is nothing but a room, okay, where there is a person who is doing something. uh, well, I say person, and that's basically takes away the whole idea of neural networks, because well, you want to avoid person. I think that's easier to understand. Okay, so now what else? So like, it's let's think about it visually. So what would happen visually is we would pass it our word arrays, where there's a first word at some point, there's last word at some point, uh, and every time there is a word that matches, okay, it will have like it will be at 0 or 1, and it will, and your model will understand that okay, at 0th position I have the word like salary, first position I have the word bonus, so on and so forth, so on and so forth, so on and so forth. Okay. Now, how many rooms do we want to add is determined by this model.add functionality. So model.add, in this one, we are going to tell it that, hey, step one, you need to do tf dot layers dot dense, and the input shape is going to be equal to vocabulary length. That is true. Then how many layers do we want? That is determined by this one, and activation is reload. Okay, so what do these terms mean? So number one, uh, how many, like our array of the array that would be an input, how many things that it would contain. So we're saying that our array will contain up until like vocabulary length, which would be, I don't know, 30. So it would be an array of up until like, let's say 30. 30, I guess it is 30, or I don't know how much this is. 20, for example, let's say. Okay, up until something. So that is, we are telling it that expect that every input that you get will be an array of 20 elements inside it. Cool. Where this is the first word, this is the second word, this is the third word, fourth word, and so on and so forth. Cool. That is our input shape. Now, the next one, we have the units. Okay. Now, the units is basically the number of neurons. So, what is neuron? Or let's say, okay, what is neuron? That is going to be a very big question. Uh, okay, very simply, let's say that this is, okay. Let me think. What's a very good example? Mm, okay, let's think about it this way. Neurons are basically the idea of the boxes, okay, or the pattern for learning. Okay, yeah, let's think about it this way. That neurons are nothing but a way of learning. So when we say that there are 32 neurons, then we are basically saying that there are 32 people in a room that are studying the pattern. Okay, the more number of neurons you have, that means every room has that many number of increased people that are learning. Should you have more people to learn or should you have less people to learn is a question. Like if you have, each array has like 20 points, 20 data points, 20 elements in the array. Should you have like 500 people learning it? uh Actually no, it wouldn't make, depending on the array, sorry, my bad. uh if you have like, I don't know, 500 of these uh data, or in this case, how many do we have? We have around 94 data, right? 94, 95, or 100, for example. Okay, let's say 100. If we have like 100 data or 100 transactions to pass to our model, should there be 100 people learning the transaction? Or should there be 10 people learning the transaction? Or should there be like how many people should be learning the transaction? So this number is, if you have too many of it, then it means that each person will think independently and there won't be any overlap. If you have too less, then you have the problem of one person kind of overlearning and some people never got the right data to learn. So we need to find a very what's the word, a very easy, or not, sorry, not easy, a very optimal number of people who are in the room who are learning my transaction patterns. In this case, I think uh, 32 is one of the most used or easiest one to kind of uh, okay, the most used number normally, as far as I've seen across. Next one is the activation layer. So activation is ReLU. What is that? ReLU. So activation is like giving the given the idea that we are using a linear unit, which means that given one input, you get you have the first layer which passes it to the second layer, which passes it to the third layer, so on and so forth. It's a very linearly connected unit, and there is uh, nothing currently which will kind of disrupt it. Okay, which will, there's nothing that adds some bias to it. There's nothing which kind of disrupts the pattern so that you learn better. There's no shuffling going on or anything, and that is where this activation function comes into picture. Okay, so the activation function, the idea is that, okay, given some data, given some like this is your data. If you give it some data, then you want it to kind of not learn linearly, not learn that, okay, this is 1, this is 2, this is 3, this is 4. You have to go like, okay, I learned 1, let's learn 3, and then learn 2, then learn 4, then learn 9, then come back to learning like 5 or something. So in that this always ensures that uh, what's the word, it learns better. Yeah, it will learn better because otherwise it will only learn in a very linear fashion. So a very good example would be, if I give it my photo, if I have my photo, if I'm a box, like if I'm SpongeBob, I think then it would be like, okay, there is no curves. We are dealing with like horizontal line, vertical line, and that's it. Okay, like that's how every person looks like. But if you give it a photo of my face where it has to understand ears, which is like uh, elliptical, eyes which are also elliptical, nose which is more of a triangle maybe, so on and so forth. So now you're giving it, now you're adding some non-linearity to the data, and this helps it learn better because now it understands what, like, you're kind of jumping around, okay, while learning. So you have to be better at learning so that you don't lose focus. Like these are some of the terms that come to my mind to explain that. So ReLU, rectified linear unit, I think it's called. Yes. Uh, so that is the. So now we have technically defined how, like, what to learn, okay, and how do you do it, like how many people are there learning, how you should basically learn it. Like you have the activation as ReLU, you have some other as well. Like, okay, try and learn using softmax kind of. Okay, which means that uh, I don't know, convert it to some other format of learning. Uh, Linear is just learn one at a time, go in a linear fashion. So it's too many. We will not know for sure which is the best one until we try each of them and see what works out for us. Okay. Uh, okay. I tried some more code, but we are at the end of this one, like this session. So what I'm going to do is we are going to take a quick pause here and we will come back after 15 minutes. It is 9:08. By the time I end this session, it would be 9:10, and then 15 minutes later is 9:25. I'll start the stream at 9:20, and then we will take it from there. Okay. Any questions, anyone, before we end the stream? Hopefully, everything that we have done so far has made sense. I've tried to think of analogies, which are more understandable. Example, like people in a room reading photos, cutting it off, uh, understanding each pieces, each pixel, kind of. Try to think of examples which would make much more sense. But if at any point you feel like, okay, I didn't this doesn't make sense, can you explain it, or can you think of another example, a real life example which will help me form an analogy? Please do let me know. Or you can do one better. You can actually let me know as part of feedback. So here's a link to the feedback form. If you like quickly go there, and this was 5, right? Finance tracker part 5. Okay. You can provide quick feedback about what do you think of this particular session? Did you like it, not like it? And any constructive criticism that you have for this session, all really, really welcome. I'll try and improve on it. Uh, but yeah, that is what I want to end up with. Uh, Thank you so much, everyone. I will see you back in, let's say, 15 minutes. I will start the stream after 10 minutes, but you don't have to join, or you can join and keep it. Let's take a quick 15-minute break and come back where we'll try and finish this function, see it in action, and then what I'll do is I'll also upload the CSV data, push it on GitHub, and we'll take it from there. Cool. Okay. Any questions, anyone? If no, thank you so much, and I will see you back in 15 minutes. Cheers. Bye bye.